Okay, class, welcome back to the course power station practices. So in the last unit, that is unit number 10, we discussed about load curve, load duration curve, then load factor, and last diversity factor. So in the diversity factor, I told you that diversity factor is always greater than unity. Okay, why? Because we say that it is the ratio of individual sum of individual maximum demands divided by the maximum demand on a system. So this maximum demand on a system, it will never be equal to the sum of individual maximum demands, because we are not going to keep all the load on all the time. Like during the daytime, we will not turn on lights. Okay, the lights are to be turned out only in the evening or during the night. Okay, so that is the maximum load on the system. It is always less than the summation of the individual maximum demands. I explained this with the help of examples where I said I have three lights, one heating element and one fan in a room. Okay, so I'm saying that this maximum demand diversity factor, that is it should be always less than equal to 1, and I should told you that diversity factor should be high. Okay, it should be high. If diversity factor is high, means numerator is more than the denominator. That means we are saving energy, we are conserving energy, means we are only turning on the necessary equipments which are required, and all the equipments which are not required or which are not necessary equipments. Means presently, what is the necessary equipment? The necessary equipment is geyser and room heater. Okay, so is the ceiling fan a necessary equipment right now in this season, winter season? No, so we will keep it off. Okay, so only the necessary equipments, they are turned on, and rest of the electrical equipments, they are turned off. Okay, so this helps us in saving the power or saving energy, so it leads to energy conversion. So what is our aim? Our aim is that the diversity factor, it should be high. Okay, so how can we make the diversity factor high? There are 5 rules for increasing the diversity factor. Okay, 5 rules. So I told you yesterday that I will explain these rules in today's lecture, that is lecture number 11. Lecture number 11. So firstly, I will write these rules and then I will explain. Number one, first rule is that what we do, means right now we have a shortage of power in valley. Okay, so what we do most often, what people do, they turn on their geysers in the evening, means at 11 or 11 p.m. or at 10:30 p.m. you turn on your geyser. Okay, so that whenever you wake up in the morning, you will get hot water. Okay, so why are we turning on geyser in the evening? Because we know during the daytime the load is very high. Okay, so what we do, because in order to avoid this power cuts because of overloading, what we do, we turn on our geysers in the evening, we turn them on. Okay, so means during the offload period, during the off peak period, when the load is not high, at that time we are turning our geysers on. Okay, so I am saying the first point is, it is related to the why I am giving you an example of this geysers, turning on the geysers during the night time, because it is first point is directly linked to that. So first, incentives to users for intense incentives to users for using electricity during light load periods. Okay, suppose that we have a few industries. Okay, so what we are doing, we are saying these means industry means people. Okay, you turn on your industry during the night time, because during the night time the peak is very the load is small. Okay, we don't have a peak load, it is a off peak load period. Night period means off peak load period. Okay, I have shown yes this off peak load period with the help of this load curve. So we tell them during the off peak load period, turn on your industry, turn on your equipments. because at that time we have enough capacity but the load is small. So we are saying to certain customers we will offer them, we will give them offers like, okay, if you will turn on your industry, if you will turn on your electrical equipments on during the off peak load period, we will give you some incentives can be means you can give them some rebate in electricity bill, some sort of discount in electricity bill. Okay, so that is one thing. Or another example is like this irrigation system. Okay, irrigation system which is very frequent in states like Punjab, Haryana, UP, Maharashtra. Okay, so what we do, we can tell the farmers, okay, what you do, you have to means water your fields. So what you do, you try to water your fields during the off peak load period. Okay, or during the off peak load periods you can turn on your this these underground these water pumps, okay, for pumping the water and irrigating the fields. So if you will do that during the night time or during the off peak load period, what we will do, we will give you some relaxation in your electricity bill. Okay, so that is another thing. So irrigation to be carried out during off load period, during off peak load period. So obviously means the industries which are consuming electricity, they are getting bills in lakhs of rupees. Okay, suppose some industry is getting bill around 50 to 20 lakhs, 50 lakhs to 60 lakhs. So if the this power industry, if they will give them an offer that, okay, since you are a big consumer, so if you are consuming such amount of electricity, it is means affecting our grid. So what you do, if you will turn on your industry during the off peak load period. Okay, so then we will give you 10% concession in your bill, electricity bill. So if his monthly bill is around 60 lakh, that 10% of 60 lakh is around 6 lakh. So 6 lakh he can directly save. So instead of means running his plant during the daytime, if he will run his plant during the night time, he can save 6 lakhs per month. Okay, so in a year it can be 72 lakh. He can means make a profit of up to 72 lakh. So on the other hand, the power company which is supplying power, so they will have to means their peak load will reduce. So if their peak load will reduce, what will happen? They can use a plant of lower capacity. They can install a plant of lower capacity. So their investment cost for constructing a power plant, it will be reduced. So both the this power supplier as well as the power consumer, they will be benefited by this. Okay, so this is the first point, incentives to users for using electricity during light load periods or off peak load periods. Okay, the second point is use daylight, or that is called as use daylight, or it is called as daylight saving. What is daylight? See, right now you can see that if I have three lights in my room, I'm not turning on any light because the sunlight is enough for me to prepare this lecture. Okay, so this is comes under daylight saving. Means try to do your complete your activities, daily activities during the daytime, and this will lead to the saving of the electricity during the night time. Okay, so this is called as daylight saving. Third, staggering of office timing. Staggering of office timing. So staggering of office timing, by staggering of office timings means that the standard time in winters, it is 10 a.m. in the morning. At 10 a.m. all the offices start working. Okay, so if all the offices and industries, all the means activities that are carried out during a daytime, they start at the same time, 10 a.m. in the morning. So obviously the load will suddenly increase, and the load will means all the means at 10 a.m. all the means people, they will start coming to office. They will start turning on their computers. All the workers, they will start coming to their factories. They will start means turning on their machinery. So this way the peak load will occur at one time. Okay, So staggering means we will divide the office timings. We will think that certain offices they will start at 8 a.m. in the morning. Okay, and certain offices they will start at 10 a.m. in the morning, and certain offices they will start at 12 a.m. in the day. Okay, 12 a.m. is midday. Okay, so what we are doing, instead of starting all the offices at 10 a.m., we are start dividing it into three categories. One will start at 8 a.m., maybe it's the educational sector. Okay, or the industrial sector, it will start at 8 a.m. Then the educational sector, they will start at 12 a.m., 10 a.m., and some other sectors which are not as important, so they will start at 12 a.m. So this way what we do, no, their peak load will if they are starting at 8 a.m., their peak load will start at suppose 9 a.m. If they are starting at 10 a.m., their peak load will reach their load will reach to its peak value suppose at 11, and their load will reach to its peak value suppose at 1 p.m. in a day. Okay, so what we are doing, the we are means trying to reduce the peak load. How? Like this, I'm saying it is suppose 10 a.m. in the morning, 10 a.m. in the morning. So initially the load is like this. So the load will start rising here and it will come like this. So then suppose I'm saying this is suppose 12 a.m. in the morning. So I'm saying the load will reach to its peak value at 12 a.m. in the day. Okay, so what I am doing, no, I am dividing the office timings into three categories. So what will happen? So instead of this, the load will go like this. I will draw it here. So the load will, if I am starting at AM, the load will go like this here, and then it will go like this, and then it will go like this, like this. Okay, because here if I'm starting at 10 a.m., around 12 a.m. the load will reach to its peak value, because all the offices will start means running their all equipments around 12 a.m. Okay, no, but I am dividing it into three means I am staggering the time office timings into three categories: one at 8 a.m., one 10, and at 12. So what is going, the peak will go like this. Okay, instead of one peak, we will have multiple peaks depending upon how we are dividing the timings. So if we can just say one at 8, 10, and 12. So if I will divide it more like 8 a.m., 9 a.m., 10 a.m., 11 a.m., and 12 a.m. into five categories, then we'll have five peaks. But obviously the peak will be lower than this initial peak. Okay, so this is called as the staggering of the time offices. Third point. Now fourth point is different time zones. Different time zones. This different time zones concept, it is mostly means possible in countries with large geographical area. Large geographical area. Okay, so normally possible in countries with large geographical area. Suppose if we'll talk about India, we have in the extreme east part, we have Arunachal Pradesh, and in the extreme west we have Gujarat. Okay, so and you know that the motion of the earth, it is this anti-clockwise. Okay, so the obviously the sun rises from earlier in east. Okay, in the Arunachal Pradesh, and it and we will have a morning first in the Arunachal Pradesh, and then we will have a morning in Gujarat. Okay, and there is a difference time lapse of 2 hours. Okay, means the sun will rise 2 hours earlier in Arunachal Pradesh compared to the Gujarat, because of the rotation of the earth, and because of the distance between Arunachal Pradesh and Gujarat. Okay, so you see, because of this this means huge area, so there is a time gap of 2 hours. Okay, but still, since we are following the standard time, we are following the standard time, so we are saying that what means time across the whole country, it is same. So means suppose if we are talking about this 6 a.m. in Gujarat, or 7 a.m. in Gujarat, at 7 a.m. in Gujarat we will have means we will say it will be like the beginning of the day, and at 7 a.m. in Arunachal Pradesh we will have a means means I will say it will be a brighter more brighter there, because the sun has because this Arunachal Pradesh, it is actually 2 hours ahead of Gujarat. Okay, so यहाँ पे दिन पहले स्टार्ट होगा अरुणाचल में, इन गुजरात जो दिन होगा वो बाद में स्टार्ट होगा. ओके, सो व्हाट वी डू इन डिफरेंट टाइम जोन्स actually. Again, I will draw the first load curve. This is power with respect to time. So I'm talking, suppose this is the load curve like this. Okay, it can be any shape. So this is my peak load. Okay, so what I can do, as can be seen, if I'm dividing the country into 2 time zones. Okay, so the half of the left side of the country, okay, that has one standard time, and half of the right side of the country that has another standard time. So means obviously both the in both the regions the day will start at different times. Okay, so and their peak loads will occur at different times. So instead of this peak, what we'll have, we will have like peaks like this, like this, like we will have like this. We will have, instead of one peak, we will have 2 peaks. Okay, so earlier the peak load was this x, now the peak load is this. Suppose I will write x1, now the peak load is x2. So this much is the, how much peak has been reduced. So it is x1 minus x2, this x1 minus x2. अब इतना पीक हमने रिड्यूस कर दिया. अब इससे क्या फ़ायदा होगा, what is the benefit of this? So we have reduced the peak by this much, it is equal to x1 minus x2. So we can supply the power by installing the power plants of lower capacity, because it is not easy to means if I am talking about because I am saying, since I have divided the country into 2 time zones. Okay, so what happened, the maximum demand in one time zone occurs at one time, and the maximum demand in the other time zone, it occurs at another time. So we will have, instead of one, I will have 2 peaks here. Okay, so when I was having one standard time, the maximum demand was occurring at one time. Okay, so because of this 2 time zones, the peak demand has been reduced. So this will reduce the construction cost of power plant, as well as construction cost of transmission system. Okay, how much? Because now we have to generate less power. पहले हमें पावर कितना जनरेट करना था, x1. नो वी हैव टू जनरेट पावर x2. Okay, so we are saving how much power, x1 minus x2. So this power, it can be supplied. For supplying this power, what we need power plants of lower capacity. So lower capacity means lower construction cost, higher capacity means higher construction cost. So if I will give a rough estimate, so for generating 1 megawatt of power, the cost is approximately around 2.5 to 4 crores. It was earlier, maybe because of some recent advancements in technology, maybe the cost has reduced, maybe from 2.5 to 3.5 crores. But initially, it means a few years back, if I will say, when I was reading this subject, when I was a student, so the cost, generation cost for 1 megawatt of power, it was 2.5 to 4 crores. Okay, so if x1 is 100 and x2 is 70, so how much megawatt we are saving here? 30 megawatt. So for generating 1 megawatt, I need minimum 2.5 crore. So if I'm reducing the peak by 30 megawatt, so 2.5 multiplied by 30. Okay, 75 means 75 crores can be saved. This is only about generation. So no, once you have generated the power, you have to transmit this power using transmission lines. Okay, and for transmitting 1 megawatt of power, you need 2.5 to 3.5 crores. This is an approximate value. This is an approximation. Okay, so for 30 megawatt, how much? If I will take 2.5, again 75 crores. So 75 plus 75, how much I am saying? I am saying 150 crores. Are you getting it? So by using different time zones, okay, so we can save hundreds of crores, maybe thousands of crores of money. Okay, so this was the fourth point. that is different time zone, because by using different time zones we will each time zone we will have each time zone the maximum demand will occur at different time. Okay, so this will reduce the peak demand of peak demand when a single time zone was used. ओके जब एक ही स्टैंडर्ड टाइम यूज़ किया जाता था तब हमारे पास एक मैक्सिमम डिमांड होगा। अब मैंने दो स्टैंडर्ड टाइम यूज़ किए, अब मेरे पास दो मैक्सिमम डिमांड्स आएंगी बट एट डिफरेंट टाइम्स। और ये जो दो मैक्सिमम डिमांड्स होंगी ये क्या होंगी, ये कम होंगी एज कम्पेयर टू द सिंगल मैक्सिमम डिमांड जब मैंने एक सिंगल स्टैंडर्ड टाइम यूज़ किया था। होप द आइडिया इज क्लियर टू यू। नो द फिफ्थ पॉइंट इज टू पार्ट टैरिफ। Okay, in two-part tariff, mostly we charge you for kilowatt hour. Okay, how much energy you are consumed, it is given as by unit kilowatt hour. Okay, so one way is this, that you can charge the consumer for this, how much energy it is consumed. Second method is that you can charge the consumer for charge consumers which are means I can say you can means give some incentive to the consumer whose power factor is better. Means incentive to the consumer for better power factor. Okay, because you know that P is equal to root 3 VI cos phi. What is this cos phi? It is nothing but power factor. Okay, cos phi is nothing but power factor. So if a consumer if a consumer he installs a power factor correction device at his terminal, so what will happen, the power which he is consuming, okay, he is consuming that power at a lower value of current. Okay, so if he's consuming this power at a lower value of current, the losses in the system will be reduced. Okay, so because of this the consumer whose power factor is better, the power quality is improved. Okay, because we are reducing the losses in the system. Okay, so for I am saying for a certain amount of power at constant voltage, if power factor is high, what will the current will be low. Again, I will repeat that for a certain amount of power consumed at a constant voltage, okay, if power factor is high, the current will be low. If the current will be low, the losses will be reduced because the losses are I square R. If the power factor is poor, what will happen? If the power factor is poor, the current will be high. If the current will be high, the I square R losses will increase. So which is ultimately to be paid by the utility. So what these utility people do, they means give some incentive to the consumer whose power factor is better, and they will charge extra money from the consumer whose power factor is poor. Okay, so so these were the 5 methods for achieving the higher diversity factor. Try to means understand these parts. If you will say this staggering of time offices and this different time zones, the funda is same in both the cases. That is point number 3rd and 4th, because in both the cases we are trying to we are trying that the maximum demand should occur at different time intervals. Okay, so next is plant capacity factor. Plant capacity factor. So by plant capacity factor, I mean that actual energy produced in a year divided by maximum possible energy that could have been produced. Maximum energy that could have been produced. So if I will say in other words, actual energy produced in a year, it is average demand, because average demand multiplied by the time in hours, it will give you actual energy produced in years, divided by maximum possible energy that could have been produced. So maximum possible energy that could have been produced, I will say it will be installed capacity multiplied by the time in hours. Okay, so time in hours will be the time in a year, or number of hours in a year. It is present in the numerator and denominator, they will cancel each other, so I will be left with average demand divided by the installed capacity. So what do you mean by better plant capacity factor? If plant capacity factor is better, that what does that mean? That means maximum how much energy you could means produce, ठीक है ना? So the actual energy that you have produced, it is as close to the maximum possible that you could produce from a plant. ओके, एक्चुअल कितना तुमने ये प्रोड्यूस किया, ओके, वो कितना क्लोज है कि आप मैक्सिमम कितना कर सकते हो, ठीक है? सो प्लांट कैपेसिटी फैक्टर इट विल गिव यू मीन्स an idea how effectively you are using a plant. Okay, so you can say this plant capacity factor, better plant capacity factor, I will write plant capacity factor means that we are using the existing plant optimally. Okay, so next is plant use factor. So this plant use factor, it is defined as actual energy produced divided by plant capacity in kilowatt. This is kilowatt hour multiplied by time in hours. Time in hours for which the plant has been in operation. Okay, so one thing I would like to say here, so this is plant use factor, कितना effectively आपने plant को use किया, ठीक है, कि actual कितना produce किया, और उस टाइम के लिए, उतने टाइम के लिए जितने के लिए आपने प्लांट को ऑपरेट किया था, उतने टाइम के लिए कितना कर सकते थे मैक्सिमम. ओके, सपोज आई एम सेइंग कि एक्चुअल एनर्जी मैंने किया जो प्रोड्यूस हुई, इट इज़ एक्स किलोवाट आवर, जो मैंने एक्चुअली उससे निकाला, डिवाइडेड बाई प्लांट कैपेसिटी, सपोज इट इज़ वाई, और कितने टाइम के लिए प्लांट मैंने ऑपरेशन में रखा था, इट इज सपोज टी. ओके, हाउएवर दिस इज प्लांट यूज फैक्टर, दिस इज प्लांट कैपेसिटी फैक्टर. यहाँ पे प्लांट कैपेसिटी मल्टीप्लाई बाय टाइम दैट फॉर विच दैट प्लांट हैज बीन ऑन. यहाँ पे था मैक्सिमम पॉसिबल एनर्जी दैट कुड हैव बीन प्रोड्यूस्ड, मीन्स इंस्टॉल्ड कैपेसिटी मल्टीप्लाइड बाय टाइम इन 1 ईयर. ओके, डिनोमिनेटर में, और एक्चुअल एनर्जी प्रोड्यूस इन अ ईयर था एवरेज डिमांड मल्टीप्लाइड बाय दिस टाइम इन अ ईयर, कितना टाइम के लिए आपने ऑन रखा था उसको साल में. ओके, सो वन थिंग आई वुड लाइक टू एक्सप्लेन हियर, देयर इज अ स्मॉल डिफरेंस बिटवीन लोड फैक्टर एंड प्लांट कैपेसिटी फैक्टर. ओके, load factor, if you load factor, if I will tell you, it is average load divided by maximum or peak load. ओके, सो इट डिपेंड्स अपॉन लोड हियर. डिनोमिनेटर में देखो लोड कितना है, पीक लोड कितना था, मैक्स एवरेज लोड कितना था डिवाइडेड बाय पीक लोड कितना था. हाउएवर plant capacity factor, it deals with the capacity of the plant. It is average load or average demand divided by the installed capacity. plant का capacity कितना है, और यहाँ पे कितना था आपका लोड का, जो मैक्सिमम लोड था वो कितना था. सो दैट इज द डिफरेंस. सो प्लीज ट्राई टू कीप दिस इन माइंड while solving the problems. So I think this 30-minute lecture is enough, because yesterday I prepared a lecture for 40 minutes and it was around 4 GB lecture. A 4 GB lecture. It took me around 12 hours to upload that lecture, this 40-minute lecture. So I have decided that I will make a lecture of 30 minutes maximum, not more than 30 minutes. Okay, because a 30-minute lecture in the online mode means that it is around equal to 50 minutes lecture in the this offline mode, because in the offline you have to rub the board, you have to means explain to the students, you have to write and explain, but here everything is explained on a page, single page. So that's why it takes less time to explain. Okay, so thank you very much. Please watch these videos, and in case you have any confusion, you can call me during the working hours. Thank you very much.